Hey folks, and welcome to session 2 of Introduction to Android using Kotlin. Today, we're going to continue where we left off in the last session, and we're going to take it one step further by building our very first Android app, which will be a chat app. We're going to revisit some of the basics covered last time in a little more detail, and we'll also introduce a cloud backend, which we'll be using, and it's called Firebase or Cloud Firebase. Well, Firebase or Firestore, these names are kind of interchangeable. The more modern version is Firestore, but you will run into the name Firebase quite often, especially in the documentation. Then we're going to dive right into the code and see how it all works together. So for those of you just joining us this session, let me reintroduce myself. I'm Adam, and I've been writing Android code for the last 8 years, and I'm a Google certified Android engineer. Android has been my favorite mobile OS, and I've built production apps of all sizes and worked with many international clients. As we're going to see today, Android is fairly simple to pick up, as the main language behind it is now Kotlin. We talked a little bit about Kotlin last time, and we're going to be using it today. And Kotlin is based on the very common language Java. As we covered in the last session, it's a modern and powerful language that's designed to make your life easier as a developer. So let's get right into it. As we touched on last time, there are 4 main components in Android. They each serve a different function and can work together to make up the entirety of your app. They are, once again, an activity, a service, broadcast receiver, and content providers. You don't have to use all of them in every app. We mentioned that last time also, but most commonly, you'll be using activities and services. In fact, we'll be using both of them in today's app. What I'm going to do today is I'm going to be switching back and forth between the slides and Android Studio. And I suggest you watch this presentation in full all the way to the end before trying out some of the things we'll cover today, so you can get the most out of it. I will be providing a link to both the code and the full tutorial at the end of the presentation, so you can focus on getting familiar with the tools and concepts during this talk. Android Studio. So Android Studio is the best tool to build Android applications. You can download Android Studio through the link on the screen. And of course, you can just go on Google, type Android Studio. It's going to be the first result. So you can just go there, download it, and download the version that matches your OS. It works on Mac, Linux, Windows. So as I mentioned, for the next few slides, we're going to be switching over between the slides and Android Studio. So I'm going to go ahead actually now and launch Android Studio. And what I'm going to do now is I'm going to start from the very beginning. Let's create a new project. So as soon as you download Android Studio, this is the welcome screen. I'm going to click on Create New Project. We're going to go with Basic Activity, which gives us a bunch of stuff in the activity, like a little button, a menu on the top right, which is these 3 buttons here. And that'll be kind of a good starting point for us. Let's just leave it at my application for now. We're not really going to be using it all the way to the end. And it's going to take a second to load all the code and do a sync. And there we have it. So we have our main activity and 2 fragments, a bunch of fragments here. Let me switch back to the slide so we can talk about the next thing. All right, let's talk about the manifest. So the manifest is a kind of directory, not like a computer directory, more like the directory or the index of a book. It tells you everything that's in the book. So likewise, the manifest tells you everything that's in your application. That's where we declare all our activities, all our services, but also some metadata. So let's take a look at the manifest of the sample app that we just created. So also worth mentioning, I touched on this last time, but I'll kind of revisit it now. So in Android Studio, on the left-hand side, you have the project pane. So if you accidentally close it, which I definitely did when I first started out, and it took me a while to figure out where it was, it's right here on the top left. So you can just click on it and make sure you're in Android viewing mode. So there's different modes. We're going to be focusing on Android, but also project mode a little bit later on. So make sure you're in Android mode. And when you're in Android mode, it's going to kind of group everything in a way that's easy to find and easy to navigate through. So if you go under the manifests folder, you should be able to see the manifest. And this is the manifest. So if I kind of collapse everything, so you can use the plus and minus icons, which are on the left side of the editor, to collapse and expand different components of the manifest. And the manifest is written using XML. So if we kind of collapse this, we can see that this is our entire application. So everything goes within this application tag. If we open it up, we'll see that the activities within our application are all listed here. Now, you could have activities that don't live here, but they're not going to be recognized by the app. As in, if you try to launch it, it's basically going to crash, and in the crash, it's going to give you an error that says, "Have you declared this in your manifest?" So it's going to give you a hint that you need to add this to the manifest. So if it doesn't live in the manifest, it's not going to be expected to be in the app, and you're going to be getting a crash. So as I mentioned, we have activities, we have services, we have content providers and broadcast receivers. All of those will need to be declared here. There's also a bunch of extra stuff like metadata. We'll visit that a little bit as we move along into this presentation. One thing that I want to mention here before we move on is that you can only have one launcher activity. That's the entry point of your app. So as soon as you launch your app, Android knows to look for a launcher app. And the way we recognize the launcher app is with this intent filter tag. An intent filter is it's essentially a type of filter that classifies your apps with certain certain actions. So for now, we're saying that the action of this activity is main and the category is launcher. This is standard. So whenever you want to make your activity the first one, the one that's going to be launched as soon as you launch the app, you're going to have to make sure to include this entire block, the intent filter block, and within it, make sure to have exactly what you see on the screen, which is name equals android.intent.action.main and category android.intent.category.launcher. Now let's talk about Gradle. So Gradle is the build system in Android. What that means is it packages up your app so we can upload it to the Play Store, and it comes with some pretty powerful features. So it's written in the Groovy language. We're going to look at it in just a second. It allows you to do different configuration options for your application. And this is also where we list all our dependencies. We can also list different variants. So maybe you can have a free version of your app and a paid version, and they can live in the same code base. But you can also have different build types. And a build type, example of a build type is like debug and release. So maybe in the debug version, you want to have some logging, some extra logging, or have test data rather than production data. And in the release version, maybe you want to be using live data instead. And the way that we specify different build types is also within Gradle, or the Gradle file that we're going to show right now. And there's at least two Gradle files that you're going to find in your project. A top level one, excuse me, and one for every module that you create. For now, we just have the one module, which is app. So there's going to be two Gradle files, one in the root and one in that module. It also allows us to create custom tasks. So for example, whenever you want to build your APK, so that's the Android package, essentially it's running a Gradle task in the background. It just packages up all your Java or Kotlin files, all your XML, all the resources into a zip file, and it gives it an extension of APK, and then you can push that to the Play Store, or pass it to a friend to check it out or to test it, and all that is done using Gradle. Let's take a look at Gradle now. You can see here that Gradle will be under Gradle scripts. If you kind of expand this, you'll see at the top level, there's two Gradle files. There's one which is at the root of your project, and don't be too worried if you kind of don't recognize what it's saying here. You're going to get familiar with this eventually. For now, all you need to know is that this is just some configuration, and it also shows like where to get the libraries, what kind of repositories, and repositories are essentially where libraries live in the cloud. So you don't have to go and download them and include them in your project. You can just kind of list the repositories here, and then whenever you add a library that's in those repositories, then Android Studio and Gradle know to go grab it from there and include it in your project. The other one, which you're probably going to be using more, you're going to be using both, but this one you're going to probably be using more. This is the per module Gradle file. It's a slightly different structure, but there are kind of some similarities. And looking here, at the things that you're definitely going to find in every project, there's going to be plugins. So this kind of classifies what kind of app it is. So this is an Android app, and we're using a plugin also called Android.application. This just tells Gradle how to recognize the files that are in this project and to classify it as an Android application. There's a block called Android, and here we specify some Android configuration. It's called compile SDK version, and also you're going to find min SDK version and target SDK version. Just a quick summary of those three. Essentially, you want to be targeting devices of a certain version, or also called API levels, and maybe you're shipping a feature that wouldn't be compatible with an older version of Android. So you want to make sure that you specify the minimum supported version, but also the target version. So maybe you can support a lower end device and disable some features on that device, but have the full features on a higher end device. So you would basically be messing around with these values. We talked about build types. So now we just have the one build type, which is release, but you can kind of copy and paste this block and create another one called debug, and it would automatically create two build types. And then you can kind of specify what goes into the release, what goes into the debug. The final thing that I want to mention, and we're definitely going to be using today, is the dependencies. So as I just mentioned, we could fetch libraries from different repositories. And the way we do that is by typing in implementation and then the name of the library, or kind of the standard name that's provided. You'll find that on the website of the library. You just plug that in, and then finally you just specify a version, or as you can see here, you can also put like a variable for it. And the variable can be defined actually in the root gradle file. So for example, here, Kotlin _version is 1.4.31. This just kind of is a shortcut, so you can kind of have all your versions in one place instead of having to dig into the secondary Gradle file. So these are all the dependencies in this project. As you can see, there's a bunch of Google stuff, one JetBrains, Kotlin dependency. These are all necessary, and they ship with your app. If you remove any of them, in fact, you can probably remove the test ones if you're not going to be including any tests, but most of these you definitely need to, as a minimum, to run your application. Now let's talk about resources. In Android, generally you'd be bundling some resources with your app. So like the app icon, the layouts, and maybe any drawables. And a drawable could be like an icon or an image, or really anything that's visual, that's seen on the screen. I already talked about layouts. So all the screens have an XML layout. All the menus, so the three little dots on the top right, that's a menu. You can also kind of design the menu by providing an XML. And finally, all the values that need to be in your app, you can separate them from the code, so you have one centralized place to look at them. So strings, which essentially means text, and when you put values in the strings file, you can also provide different translations. So your app, if it ships in Canada, it's going to be in English. Maybe if it ships in France, it's going to be in French, and so on. And you can provide all these translations in the strings file. You can also specify dimensions, and this allows you to have different dimensions for different device sizes. You can also have different colors, for example, for dark mode versus light mode. And you can also have different styles and kind of pick which style to use for which screen. Let's take a look at that resource directory now. So it's basically called res. Here are all the values that we talked about, the different kinds of values. A lot of them are just plain XML. So as you notice, XML is pretty popular in Android. Really, I promise there's not a third language. It's just Kotlin and XML and Groovy, sorry. So there's not a fourth language, but you don't really have to learn that much Groovy. You can just copy and paste the dependencies. You don't really have to understand it that much. But XML and Kotlin, definitely where you're going to be using, and they're fairly straightforward. Really, an XML file is just a bunch of tags, and within these tags, there's like sub tags. Right now, I'm looking at the layouts of the main activity. And in fact, I'm going to be launching this activity in just a little bit, but we already demoed it last time. And if you remember, basically the main activity looks like this. It's just a screen with a button in the middle and another button in the bottom right. They don't do much for now, but we're going to be changing that shortly. So these are the layouts. These are the drawables. You can also specify menus, and you can also specify how to navigate. You can kind of provide a navigation map. So you can just reference this map and say, go to screen 2 or go back to screen 1, and you can do all of that from the nav graph. And finally, values. So we talked about colors, dimensions, and strings, and also different styles that can be specified here. And they're all in XML. And it's good to just kind of be familiar with it for now. Most likely, as you start using your Android application or building your Android application, you're going to be familiar with all these different XML files. Fairly straightforward to be working with. All right, now let's focus on an activity for a second. An activity is equivalent to a screen. It houses all the user interface components and it captures interaction from the user. You can think of it as the main visual component of every Android screen. So if you're going to be creating a new screen, you're probably going to be creating a new activity. We also talked about how activities contain fragments in the last session. They can contain fragments. They don't have to contain fragments, but having fragments allows you to modularize your application, kind of split it up into different parts. For example, let's say you have an app on a phone, you want to show just like one part of the content, but if you have a bigger canvas, like on a tablet, maybe you want to show, two kinds of content, maybe a menu and details. So you can just specify two fragments for each of these and display them differently. Once on a phone, just showing one of them, and maybe both of them on a tablet. Fragments can also be used to swipe between different sections of the same screen. So I have here an iOS device, an iPhone, but it's the first result that I found for bottom navigation menu. And it's very common in Android as well. I probably should have spent more time to find an actual Android device, but this is Facebook. And on Facebook, if you open Facebook, you'll find that there's buttons at the bottom of the screen, but the screen itself is the same. As in, when you go to a different section, the buttons on the bottom, they don't disappear. So this allows you to, fragments allow you to, within the same activity, have different versions of the screen and switch between different sections. And we're actually going to be doing that in the example that we're going to be building today. All right, so the way we start activities in Android is using what's called an intent. It's also the same way we start a service. We use an intent as well. Intents are fairly common in Android. For now, you need to know that that's just a class. In that class, you can specify the name of the activity, and then you can call a method called start activity provided with that intent. And Android will understand what your intention is and just launch that activity. We can only have one launcher activity, and that's what we touched on a moment ago. And that's what Android knows to launch as soon as you open up the app on the phone or launch it from Android Studio. It's immediately going to go to your launcher application. You can start one activity from another, as we're going to see in the example a little bit later on. And the two more things that I want to talk about before moving on from activities is activities. We set the view by calling a method called setContentView. We're going to see that in a moment, but before we go there, I also want to touch on a method called start activity for result. So I talked about how you can start an activity from another by just calling start activity and providing an intent. You can also call start activity for result and get a result back from the second activity. For example, let's say you want to pick a picture and set it as your profile picture, which we're actually going to be doing today. The way to do that will be to start the gallery application for result, or I should say the gallery activity for result, and then it's going to pass a result back to the main activity. And this method kind of simplifies that communication, as we're going to see. Actually, before moving on from activities, I have a few more things I want to talk about, which is activities have life cycles and life cycle methods. And these methods are triggered at certain events of the life cycle of an activity. Before I kind of go into details of them, let's just go back to an activity and look at the setContentView, which I promised you we're going to go into. As you can see here in the sample app, it's the very first thing that's being called in our what's called onCreate method. So onCreate is actually one of the life cycle methods. It's called by the operating system as soon as that activity is created. So an activity is created, then the system knows now it's time to run the code that's within onCreate. It's kind of the entry point of the activity. And since this is the main activity, the launcher activity, then it's basically the entry point of your entire application. The first thing that we're doing is we're setting the content view to this resource here. And resources start with the R, capital R letter. So this basically means resource.layout. The name of the file. So we can actually find that file two ways. We can either go into layout because we're going to the resources folder, and then we know to look for the layout part of it because this says layout. And then we can just launch activity.main. But there's a cool shortcut. On Mac, you hit Command, and on Windows, you hit Control. And you can just command click on this activity main, and you will see the layout is just going to automatically launch it. But let's say I couldn't find it, or I didn't want to find it. You can also click on this little nifty target button, which will basically kind of go straight to show you where that file lives in your directory, so that in the future, you know where it is. You can just kind of launch it from there. All right, so these are the lifecycle methods. You're not going to be using all of them all the time, but they do allow you to plug into certain events. So whenever your activity is created, you can put code there. Whenever it's being destroyed, maybe you want to release some resources, or maybe you want to delete something. Whenever it's paused, so an activity is paused whenever it goes into, it's not like the main thing that's on your phone. So if maybe you get a notification, maybe you get an SMS or a message on Facebook or something, and that's kind of on top of your activity. So the activity will be paused. So let's say you're doing something that's draining the battery, like maybe you're scanning Bluetooth or you're playing a movie or something. Then you want to pause it whenever that activity is no longer in focus. And the place to do that would be in the on pause method. There's also on resume, so it's the opposite of on pause. And there's on activity result. That's another example of a lifecycle method. And this will be called whenever you have a result from an activity that you launched earlier using start activity for result, which we talked about a minute ago. There's also lifecycle methods in fragments. Most of the activity lifecycle methods actually are the same in fragments, but there's a bunch more. I just mentioned one here, which is on create view, because fragments are very similar to activities. They're essentially like sub activities. So they also have the same lifecycle methods, but there's a few more methods that are specific to fragments. I just kind of want to get you familiar with the idea of lifecycle methods, because that's where we're going to be inserting our code. In Android, whenever you create a layout, it's generally going to be a hierarchy. The top level is going to be some kind of view group, and it's a group of views. And then within it, you're going to have different views. In this example here, and of course, a view group is also a type of view which has other views within it. So everything is a view, but some of them could be view groups, which contain other views, and you can create some kind of hierarchy. So as we can see here, the top level is a view group. It's got inside it an image, some text, another view group, and that other view group has some layouts within it. We're going to be talking about layouts in just a minute. But before we do that, let's go ahead and look at the layout example that we just mentioned. I have it on my screen here. So this is the design. But if we click on code and maybe collapse some of this stuff, you'll see that it's XML, and the main view group, or the root view group here, is a type of layout called coordinator layout. There's many different types of layouts. That's just one of them. We're not going to go into details of of all of them. There's really numerous types. But as you get more familiar with Android, you're going to kind of get an idea of which one you need to use. For today, we're going to be using what's actually called the constraint layout, and we're going to talk about how that works. And it allows you essentially to constrain different views to different parts of the screen. So you can say, put this view at the bottom always, regardless of the screen size, regardless of the whether it's portrait mode or landscape mode. So it's pretty useful. It's probably the most view group that you're going to be using, the most layout root element that you're going to be using. So we talked about layouts. Here are some other examples. So linear layout, we talked about it last time. There's also relative layout, kind of old, not really common anymore. And constraint layout, very common today, where we can constrain different elements on our screen to different parts of the screen, and others as well. And one more thing I want to talk about is a modern feature of Android. So it wasn't around before. It's a little bit more recent, called view binding. View binding allows us to call the element within our layout directly from the code. Let's see if the sample application has that. I'm not sure, actually. Actually, the sample application does not have it. We have to find the view by its ID using a method called find view by ID. But in the next example, we're going to be looking at data binding, and you'll see that you can just say, so for example, you want to fetch, let's say, this floating action button. If it has a name, and it does have a name here, which is FAB, you can just say FAB dot, do whatever you want. Maybe you can give it a click listener so that you can specify what happens when you click on it, but you wouldn't have to call this ancient method find view by ID. I'm not sure why Google is still including that in their sample application. Maybe because it's just kind of tradition, but this whole line can basically be replaced by just these three letters, which are the name of the floating action button, FAB. there might be something you have to adjust in Gradle to support it. So Gradle, as I mentioned, includes all the dependencies and configurations. So maybe in this, in this configuration, it's not supported, but there is a way to add it to Gradle, and then all of a sudden your application will be able to fetch that element directly without having to call this nifty little find view by ID method. I want to talk about a special type of view called a recycler view. You're going to be using a recycler view quite often. And the difference between a recycler view and a linear layout. So if we go back to the linear layout slide, basically you can stack items horizontally or vertically. It seems like, that's all you need, right? Why would you need another view, another recycler view, especially when the name, I don't know, kind of doesn't imply what it does. So let's define what the name is, and let's kind of get into why we need another view. So a recycler view, what it does is your screen can only show certain elements. When they go off screen, we want to kind of offload them from the memory, but we want to reuse that view for elements that are just coming into view. So this way we're recycling the elements of our list, and that's why it's called recycler view, because if you don't recycle it, then you're going to have to destroy that class, or like send it off to Java's garbage collector, and then create another class. Is going to be a performance hit. Whereas you can just recycle that view, and Android automatically knows to present this new data that was off your screen. Maybe like you're looking at a contact list or something, and you're scrolling up, and you want to get like a really fast, smooth experience. So the way to do that would be to use a recycler view, because it automatically knows to apply that efficient way of displaying items on your screen. A recycler view requires two main things: a layout manager to tell it whether it's going to be a linear layout manager. So that means like things are stacked either on one on top of each other, or one next to each other, similar to the horizontal and the vertical linear layout. But of course, with all the efficiencies of recycler view. But you can also have a grid layout. So if you want to have elements stacked like in a grid, kind of like a table, so then instead of using a linear layout, you can just use a grid layout, and it has just the same efficiencies as well. If you kind of scroll through the grid, like for example, in a gallery, it will automatically recycle the views, so it doesn't take a big performance hit. You also need what's called an adapter. So an adapter essentially adapts your data to be displayed in the recycler view. And the adapter, there's an adapter class, there's a view holder class, and there's an item view class. We're going to kind of touch on it a little bit later, but I just want to mention that that's how you define what goes in your recycler view. You basically you create an adapter, and you put some data in the adapter, you just plug it in, and then all of a sudden recycler view knows which data or how to show the data into the list or the recycler view. Now let's talk about let's move away from layouts and views and talk about some of the tools that you can use whenever you're building Android applications. So the AVD Manager, or Android Virtual Device Manager, allows you to create virtual Android devices, also called emulators, on your computer. So even if you don't have an Android lying around, an Android phone lying around, you can just launch an emulator, and it's going to show up on your screen, and you can start building applications right into the emulator. There's a lot of advantages to using emulators, although you can definitely use a real device to test your application. So it's it's kind of a choice that's up to you. But of course, emulators are there, and they can be used without having to plug in any device or find the cable. You can just launch the emulator, and it's going to be on your screen. Emulators can be created from the AVD Manager, or Android Virtual Device Manager, where you specify the device type. So maybe you want the latest Pixel phone, maybe you want like slightly older Pixel phone. You can also specify the API level. So we talked about API levels. That's like the software level of Android. So is it Android 11, Android 12, Android 10? You specify which one you want to launch. So maybe you want to test on older devices running older software. You can still do that from right within the emulator, and it's very useful for debugging. It's very quick to launch your app in an emulator, kind of dig into the code and dig into kind of what's happening under the hood. And it's just a nifty little tool. You're probably going to be using it a lot. Let's take a quick look at the AVD Manager. So it's this little icon here. It's like looks like a phone with a little Android on top of it. If you click on it, It's going to launch my AVD manager. You can see I've already created a device. I'm just going to show you quickly how to create a device. You click on the biggest button on the screen, create virtual device, and then it tells you, all right, so which one do you want? You want a Pixel 4, Pixel 3, and you probably want to go with one that has this little icon here, which basically means it ships with Google Play services, which are very useful for example, for Firestore. So you're going to be needing that. So I would recommend pick a device which has Google Play services on it, but really you can pick any device that you want. Excuse me. And then you would hit next. And then it would tell you, all right, which API level or like software. So this translates to, so for example, API 30 is Android 11. If you go to API 29, so that's Android 10. You can specify the version as well, but you might have to download it if it's not available. For example, I just have API, API 30 downloaded from a little bit earlier. So that's what I'm going to pick. And then finally, you give it a name. And if you hit finish, it's going to create another device. Right now it says Pixel 2 because it's not like version 2 or like iteration 2 or like the model Pixel 2. It's just the second Pixel device that I'm going to be creating. Not really going to create it. I've already created it before. And if you click the play button, it's going to launch it, which I've already done beforehand, just to save us some time. It takes about 10 seconds, 15 seconds to launch. And as soon as it's launched, you're going to see on your screen this wonderful Android phone-ish emulator that you can launch all your apps on, and you can kind of plug into it and do all kinds of fancy things. There's all these buttons on the right side of the emulator which simulate a real device. For example, this is the power button. As you can see, it's like switching it off, switching it back on. You can control the volume, you can go up and down. So it's very much like a real device, and you can use it just as well as a real device to be testing your apps and to be debugging your apps. All right, let's talk about the debugger. So Android ships with a debugger, and it allows you to, it's a very important tool because it allows you to listen in on running applications and be able to kind of find out which part of your code is getting stuck or causing a crash. And you can do that by either by like, we're gonna talk about the logcat like in a second, but you can look at the logcat, but you can also set breakpoints. Breakpoints are common in a lot of different languages. A lot of different IDEs have breakpoints. You can set a breakpoint, and then let's say you put a breakpoint like in the onCreate method of an activity. As soon as you launch that activity and onCreate is called, that breakpoint is going to be triggered, and everything is going to stop. And it's going to allow you to kind of dig into that part of the code. In fact, let's do that right now. I'm just going to put a breakpoint here. So you can, if you click on debug, it's going to relaunch the application with the debugger, but you can also attach a debugger to an existing device. So I'm going to do that because I already have my Android device launched. I'm just going to pick this Pixel device here. It's not letting me. Yeah, it's not letting me because we actually haven't launched the app. So let's do that right now. There's jokes about how Android Studio uses a lot of resources, and you can probably see now why they're so funny, because it takes forever. And by forever, I mean like, yeah, go ahead.
I don't know how your laptop isn't dying right now. My laptop wouldn't be able to handle this.
Well, the room is definitely a lot hotter, so I can use it as a heater in the winter.
Yeah.
So I guess that's a plus. Cool. So now we have the application running, and now I can just click on attach debugger. Now I can see it. Now I can click OK, and you will see immediately that there's now a check mark next to this debug point that I've created. What that means is, well, the application is already created. It's not going to trigger on create again. And you know, if I exit the application and then relaunch it, it should, as you can see, Android Studio just stopped, went to that line, and my application hasn't even loaded. It's kind of like frozen into time, and it's waiting for me to either tell it to go forward or to remove the debugger entirely, or I can just kind of open up my debugger and I can peek into all the data. There's all this different data. Don't be scared of all this data. You know, usually you don't care about all of it. You just care about the data that you created. Right now, we didn't really create any variables, so we don't really see anything besides the ones provided by the system, which can be useful for debugging, but generally speaking, you're interested in the variables that you created, and they're all going to live here. And if they did, which they don't now, then you can just kind of expand them and then look at the values inside them and see, is it the value that I'm expecting? Is it like a different value? So that's, that's why you can do, that's how you can do debugging. If you click the play button, it's going to move forward, like kind of go to the next breakpoint. If there's no more breakpoints, then it's just going to continue launching the application as normal. But you can also step to the next line. So that's what I'm doing right here. I'm just kind of going line by line, executing the code line by line. And we can take a look at the data as it changes. So it's a really cool tool that allows you to know exactly what's going on under the hood. Very useful for finding bugs. I just hit play, which means continue execution. If there was another breakpoint, it would go to it, but because we only put one, it basically just continued launching our application. We mentioned the logcat earlier. I think I Googled the wrong image there, but the logcat is similar to a console, or like what consoles are in other IDEs in other languages. Basically, it's data that's being sent by the Android operating system to the output. Like it's like system out almost, and so it shows important operating system messages, but you can also do manual logging. So I could maybe put a logging message in onCreate and say, hey, onCreate was created, or I could just say, hey, Adam is cool. I can say whatever I want, and it's going to show up in the logcat. I'll show you the logcat in just a second, but also is very useful for crash logging, because if there's any crash, you're going to see a big exception in your logcat. It's also going to point to where that exception came from, and it's like a hyperlink. So if you click on it, it's going to take you straight to that point in the code. We're going to do a simulation of the crash a little bit later on, and it's very useful for debugging as well. The way to launch the logcat is to just go to the logcat tab. As you can see, there's a whole bunch of messages. We're not really interested in most of them. This is just some operating system messages. If there was a crash, it would be like lots of red, but also like not like this red, way more red. And also you can see like the name of the exception that was thrown and where it was thrown. You can just kind of click on it. It's going to take you straight to the code. And we're going to do kind of a simulation of that in a little bit. I just hit the delete button. It's going to be like very useful to know where that button is, because the logcat gets pretty big pretty quick. So it's in the top left, looks like a trash bin. All right, now let's talk about the backend. So Cloud Firestore. So this is what we're going to be using as our cloud. That means all the data that does not live on your device is going to be in Cloud Firestore, also called Firebase. Now, it doesn't just provide you with like a place to put your data, essentially a database. And first off, it's not just a normal database. It's a very cool database. It's a real-time database. What that means is it synchronizes with the database on your phone. So you don't have to fetch the data, update the data on your phone. It's always in sync. You can always just kind of create data on it. It's going to live both in the cloud and on your phone at the same time. Saves you a ton of work. Believe me, I did it the manual way, and I almost hated Android. Well, not Android, hated the idea, it has nothing to do with Android, hated the idea of having to write a database on the cloud, on my phone, synchronize them, cache them. All that stuff is done automatically with Firestore, and that's why we're using it today. It also allows you to provide user login, so you can log in using your email, you can log in using Facebook, you can log in using Instagram, really any kind of login provider is going to be supported there. We're going to do a quick tour of that in just a second. It also gives you cloud storage, so you can basically put your files, your data, images, videos, audio, any kind of data that you want to synchronize with the cloud. Like for example, on WhatsApp, if you send an attachment, it doesn't go like from your phone to the other person's phone. It actually goes to the cloud first, and then they have to download it from the cloud. So in our case, that would be the cloud storage provided by Firestore. And we also have that in the app that we're going to be creating today or looking at today. It also provides you with cloud messaging. This is a way that you can send notifications or messages to devices. It doesn't have to be like an instant message. It could be like, for example, let's say you want to send a calendar reminder, or maybe you want to create a device that makes the phone vibrate, from the cloud. You can kind of trigger from the cloud. It's going to make your users' phones vibrate at random times. It's kind of funny if you ask me. I don't know why you would think of doing that, but you can definitely do that. It's basically a way to ping from the cloud to send a message to your devices. As long as it's an Android device, it will receive your message. It also has some analytics, which basically means some metrics. So you can kind of see how your users are using your application. Maybe they're spending too much time on one page, but not the other. Maybe they're getting stuck and they don't know about a feature that you created. Maybe you put it in somewhere that's too hidden, and analytics allows you to know in real time how your users are using your application, and you can kind of get some very important feedback about whether they're using it in the way that it's expected. Are there any hiccups? So analytics is given to you also out of the box with Cloud Firestore. One thing to keep in mind is that Cloud Firestore has a massive free quota, not quote. There's a typo there, quota. And that basically means that you have a lot of free usage available to you and to a lot of users. But once you get into a very large app with a lot of user base, what's going to happen is you're going to get past the quota. It can become very expensive very fast. I think the idea here is that if you're that big, you probably could afford to to pay for this service. But also the good news is you don't have to use Cloud Firestore. I personally use it for prototyping. It's fantastic for prototyping. As I mentioned, for all the above reasons, I can be up and running with the cloud very fast. And I can, I don't have to create a backend myself. I don't have to do all these services myself, and I can just use it to test. And, if I get that big, I probably can also afford to switch to something a little bit more manual. It doesn't have to be fully manual, maybe some other service that's either hosted on my server, so it's free. I just have to pay for, the hosting, or maybe a cheaper service. But just keep in mind, it does get pretty expensive pretty fast if your app starts to have like hundreds of thousands or millions of users, because it does charge you per transaction, which means like per write. Sending a message, that's like a write. Reading a message is like a read. That's another transaction. It gives you a lot of free quota. But once again, if you have a lot of users, you will likely pass that free quota, but you can definitely still use it. And we're going to be using it today, the free version. In fact, let's do a quick demo right now. So I have the tab open right here. I've already created a chat app. You know what? I'm going to delete it. And let's kind of do it from the start. I'm just going to go to project settings. And in my opinion, they should have like a much more hidden way to delete it. It's literally like 2 clicks and your whole project is gone. Yeah, you have to click on a bunch of checks here. But bam, project disappeared forever. There's no going back.
4 clicks. There's a lot.
Yeah, it's a lot, especially if your app is in production. That's really bad. Anyway, so now we're back to the original screen that you're going to see on your if you go to console.firebase.google, you're going to see this screen. If you have no projects, then it's going to ask you, well, do you want to create a project? So hell yes, let's do that. Now let's call this awesome chat app and click continue. Do we want to enable analytics by default? Why not? And then you just click default account here. It's like the only option. I don't even know why they give you more options. Just create a new account, I guess. Cool. Create project. Should play some Jeopardy music here.
I'll do the beats.
Almost. Bam. Then you click on continue, and now your awesome chat app on the cloud is live. What we're going to do now is we're going to be quickly adding that project to our sample app, the one that we have right here, and we're going to kind of make them communicate together and start to use the cloud. I'll show you how fast it is to immediately start adding that to your application. You don't have to write a lot of code. So the first thing we're going to do is we're going to click on this little Android here. Basically, it says to get started by adding Firebase to your app. So we have an Android app. I'm going to click on it. It's the first thing you have to do is provide a package name. So the package name is actually, we provided this when we were creating our application. I told you guys last time, it's basically the reverse of your domain name and then followed by the name of your app. So, if your domain is, let's say, Adam, so it could be like adam.com, which I don't own. But then my package name could be com.adam.myapplication or my chat application. So I'm just going to copy this over there. It has to match. So com.what was it again? Example dot my application. Let's give it a nickname, chat app. This nickname is optional, but why not? Now we're going to click on register app, and it's going to give us one file. And if we include that file in our project, now they're linked forever. That's all the configuration you need to do. So I actually missed it right there. So I'm just going to download it. All right, show in Finder. Just going to copy it. I have an old one here, so I'm just going to move to trash and kind of, it has to be the name google-services.json as provided. So I just clicked on command copy. We'll go back to my project. It even shows you where to put it. It says to put it inside the app module, but you do have to switch to project view, which we talked about a while back. So instead of being in Android, which kind of shows you just the Android stuff, let's show the whole thing, which is project. And let's go into the app module, and I'm just going to paste it over here. So now these are all the credentials. If we start to use Firebase, we should go straight to that project. That's really all it takes to link your app to the project. But we can't use Firebase yet because we haven't added any dependencies. Like we didn't add the library yet. I'm just going to switch back to Android. And I do have some code loaded from earlier. If you just give me a second. Which I'm going to paste here. You don't have to follow along. All this is going to be available later, but I'll just show you how quickly it is. So the first thing we have to do, and also all this code, I actually got it from the Android tutorial, or I should say the Cloud Firebase tutorial, which I'm going to show you guys on the screen now. It's just a bunch of steps. You just have to add a bunch of dependencies, modify the Gradle files, and you're basically good to go. So I'm going to go ahead and switch back to Android Studio, and I'm going to paste all this stuff. I already have it kind of copied. I'm just going to paste it. Okay, cool. So first up, we need to add a class path to the root Gradle file. So here we just have to go under the root Gradle file and just add this line here. Once again, if you go to documentation, you're going to find all these steps, so you won't be lost. We have to add a plugin to the module Gradle file. So that's the one that's kind of one step lower in every module. Just going to add that there. And finally, we have to add the dependencies. So now we should be good to go. In my experience, though, we are going to run into a crash now. And I'll tell you now, so you don't have to tear your hair out to try to figure out why your application is crashing. But first, I'm just going to kind of let it happen. So, and whenever you make changes to any Gradle files, as you can see, it asked me, do you want to sync? And I basically said yes, which means kind of rebuild my project using this new configuration. Now let's try to launch it. I just hit the play button on the top here, and let's see if the app crashes. Just going to exit it, so it relaunches. Even if you don't exit it, it's going to relaunch it, but just kind of show you guys a fresh start. Any second now. All the fans on my computer are on.
At least it's a MacBook. It's okay.
All right. So it says cannot fit requested classes in a single DEX file. You don't have to know what that means fully. I'll just explain it kind of like in English. That basically means you've included too many dependencies, and now your app has to be split up into what's called multi-DEX. Not to worry, I also have some code to add that here. You'll see it's really simple. We just have to add one more dependency. I'm just going to add it right here. It's this one right here. It's basically support for multi-DEX. And we also have to enable multi-DEX. And the way we do that is by going up to the Android block and let's go. In default config, yeah, right here, we just add multi-DEX enabled to be true. And that should fix it. So I'm just gonna do another sync because once again, every time you change the Gradle file, it should fix it. And now if you launch it again, hopefully it's not gonna crash. But as you guys saw, the error showed up in our, actually was not the logcat, but the logcat would show up in the same way. That was the kind of the runner of Android Studio. Now it's asking me, hey, this app you have a debugger because we ran a debugger earlier. Do you want to terminate it? Let's terminate the hell out of it. So I click terminate, and now it launched our app successfully. Now our app supports Firebase, but we don't really do any Firebase stuff. But at least it launches, at least it doesn't crash. So I guess that's a step in the right direction. Cool.
A quick question: does multi-dexing affect performance?
It's a good question. It does not affect performance. It affects app size. So your app is now going to be bundled into more than one DEX. Sometimes you have to do that. There's ways around it. You can basically, instead of including the full library, you can kind of select which parts of the library that you need. And this way, you don't have to include, a lot of different it's not really dependencies that make it big. It's just the number of methods. If you go higher than 65,000 methods, you need to split them up. So it's kind of shocking that the Firebase database has, makes your app grow beyond 65,000 methods. But I guess it's a massive database. It does a whole bunch of stuff. So it's I guess it makes sense. All right. So now I'm going to add a bunch more code. Did you guys see the emulator when I ran it? I guess not.
Not the last time.
All right. Well, it ran. So I hope you believe me.
Yeah.
Cool. I mean, it didn't show the error, but I'm just going to show the whole screen just to kind of, so you can believe me. There it is. So it ran just fine. We fixed the multi-dex thing. Let's switch back to Android Studio. Now we want to add all the Firebase. Actually, no, we've already added all the Firebase stuff. So what we can do now is we can go straight to our main activity and start using Firebase. We've already added the credentials, which is like the Google Services JSON. I'm going to collapse project for now just because I made my font so big. So I just want more space. But remember, top left, in case you forget, so it doesn't take you hours to find. It's just right here. Okay, I'm going to add a bunch of code which I've prepared from earlier. In onCreate, so like the method that gets called whenever the application is launched, I'm going to add this code here, which basically says Firebase app.initialize app, and I provided it with what's called the application context as a value. The first thing you notice is that it's in red, which means, you have to import it. It's not just a matter of pasting it there. It's in the library, but you have to include it in your class. There's a shortcut to do that. So there should be a little, I think it's hidden because the font is too big. Well, if you just hit Option Enter on Mac, then it's going to kind of open. Now it's shown the red light bulb. It basically gives you suggestions. You can just click on Import, and on Windows, that's Alt Enter. It's going to pop the same menu. You just click on Import, and it will actually add it to the list of imports here. So you can see com.google.firebase.fire app has been added to the imports. So now this is ready to go. So I've added this line, but I'm actually going to comment it out for now. Like commenting it out means I converted it into a comment, which means the compiler ignores it. It's no longer code. I'm just going to disable it now, just so we simulate a real crash now instead of just like an Android Studio crash. We're going to create like an Android crash, just so we can see how that looks like in the logcat. And the rest of the code, I'm just going to paste a method here called send message. And once again, it needs to import these files. You can hit Alt or Option Enter. It's going to just import them. What I did here is I'm fetching an instance of Firebase, and what I'm doing what's called lazy instantiation. That basically means only create an instance when we need it. So this is like one way to kind of save performance. Probably won't make a big difference, but it's just good practice. Only create the instance when we need it. So kind of be lazy about it. Don't create it until we need it. And that's kind of the syntax here. And that's another thing that Kotlin just allows you to use within your code. So if you just say by lazy and then just provide like how to instantiate it, then you're good to go. The next thing is I'm going to create a value, and I call it chat channels collection reference. And I'm going to use this instance, this firestore instance, and I'm going to hit the collection method. What this does is it fetches the collection if it exists, or it creates it. Now, collections are, let me switch back to Chrome for a second to tell you what collections are. So this is our chat app. We've already added it, so we can close this guy. Actually, let's do the rest of the tour, and then we'll move back to the app. So first off is authentication. I mentioned you can sign in with your email. You can sign in with Facebook. First thing you do is just click on Get Started. It's like a little wizard. And for now, we're just going to enable login with email and password. But you can also enable logging in with phone number. So send you like a text message to your phone. You can verify it. You can log in with Google. You can log in with Facebook, Twitter, GitHub, a whole bunch of others here. And for now, we're just going to enable email and password. We're also going to initialize our Firestore database. So we're going to go to Firestore. We're going to click on Create Database. And we're just going to select Test Mode, because Test Mode allows us to read and write whatever we want. There's no rules. Of course, it's not good for production. That just means that anybody can go into your database if they have your google.json file. Remember, that's your credential file. We have it in our Android application. It has a bunch of keys, but if anybody has it, which they shouldn't, they may be able to access your database. But for now, we're just going to start in test mode, which means all the rules are open wide. And now you just have to select a location. So this location, you cannot change it later. This is where your data lives. So if you want your data to be, I don't know, like in the other part of the world, you have that option here. But for now, let's just keep it for US Central. Hit enable. Wow, it looks like it runs in the family. It's kind of slow too. All right. So as you can see here, we have a database. We can start collection. So a collection is like, it's a collection of what's called documents. A document is like a database element, and a document can contain further collections. So you can create kind of a hierarchy here, but we can create them manually. So I can just click on it now, but we don't want to do that. What's the whole point of creating an app if we're going to go into the database every time and just create it from there? That's no fun. So I'm going to switch back now to Android Studio. But actually, before I do that, let me just talk to you through the rest of the things we're going to need. We're going to need storage, obviously. You're going to click on storage. I don't think I have to initialize it. I think it's just out of the box. There's no wizard or anything. You can just use it. Yep, that's the case. And the other thing that we're going to be needing is messaging. So I'm going to go to cloud messaging just to show it to you guys now. But, well, we could send our first message. You just basically specify like the key of the Android device to send it to. But for now, I'm just going to show you where it is. And then maybe later on we can start using it. So the important thing is now our database is initialized, and I'm going to switch back to Android Studio. I'm going to continue pasting some code. So now I've created this send message method. We've already talked about getting a Firebase instance. We talked about creating a collection or fetching it if it exists, and we're going to call it chat channels. Then the next thing we're going to do, now that we have a reference to that collection, that basically means like we're pointing to that collection. We can do whatever we want in it. So we can do .document, which will either fetch the document that's there or create it if it doesn't exist. We're going to give the path or the name of the document the name test. And within that document, we're going to create yet another collection called messages. So we have a chat channel, and within that chat channel, we have a collection of messages. Because we can have multiple chat channels, that's a collection. We can also have multiple messages in every chat channel. That can be so that will be a collection as well. And finally, when you hit add, that will basically add a document to that path. So it should go to chat channels /test/messages, and then it should add whatever message that we send here. And as you can see, I've specified the type to be a hash map. This is just a map, and I specified the key to be a string, and the data could be integer, could be anything. And in Kotlin, we have this fancy word any, which basically means any data type. But as you can see, the method is grayed out, which means we actually haven't used it anywhere. So let's go ahead and call it somewhere from within our code. Let's put it in the floating action button, which right now, so as you can see here, if we click on it, I'm going to actually show my full screen again. If we click on the floating action button, it just says replace with your own action. Wow, don't tell me what to do. Okay, fine, I'll do it. So it says here, replace with your own action. That's what we should be replacing it with. This is the code that triggers that. So what we can do now is just kind of replace it with our own action. I'm just going to delete this, and I'm going to paste some code. We're going to create a hash map of some data, and then we're going to pass it to our send message method. Now remember, we intentionally created a situation where it's going to crash. We did not initialize our firestore app. Now let's see what's going to happen if we try to launch it. Once again, we're going to terminate the old instance. So it's just going to close it down, open it up again. So the app launch is fine. Crazy. Now let's see what happens if we click on the floating action button. It should send a message to our database, but it's taking a second to crash. Taking a little bit more than a second. Or did it actually work? I don't see a crash. Let's check to see if the database was initialized or if it made it. Wow, it made it. It did not crash. That's crazy. Okay, so we can try to crash it some other way. But as you guys can see, that's all it takes to communicate with our cloud. We created our cloud, and then we have chat channels, test messages, and sure enough, the document ID is auto-generated, but you can specify an ID for it. And sure enough, you can see here first name, last name, message, and middle, which basically these are all the parameters that we provided. So there you have it. That's our chat app. Thank you very much for joining me. See you next time. I'm just kidding. I'm just showing you now that this is how you connect with the cloud. Obviously, we don't want to be chatting with our database. It's not very useful. Nobody else can see the database. I guess it's a single person chat, but we're not displaying in any kind of way. So let's switch back to the slides and see how we can kind of take things from here. We've already connected Android Studio, or I should say our Android project to our Firebase cloud instance. It should have crashed, but maybe they updated Firestore so that it doesn't need initialization anymore. So let's see maybe if we can do something else to make it crash. Let's see. Maybe I can set it to be nullable and then try to access it. Okay. So instead of providing a hash map, I'm just going to say null. So now it's nullable, and because the method signature is not nullable, we talked about, how the compiler is going to complain. It's going to tell you, hey man, it should not be nullable because your method is not like the signature is not nullable. So I'm going to make it nullable here. And that kind of, well, that also complains because we cannot provide something nullable here. So what I'm going to do is I'm going to force, I'm going to make it kind of ignore. I put the question mark in the wrong place. I should put it here. And now it complains just about the message. It says, and if I hover over it, it says type mismatch. It could be anything except for nullable. It found something that's nullable, so it won't work. So instead, I'm going to put the double exclamation mark. There's a reason why they made a double exclamation mark. So you have to be absolutely sure that you want to use something that is nullable because it could be null, which is exactly the case for us. So now it should crash. If it doesn't crash, then it's too smart. There we have it. So that's what a crash looks like. It just disappears. And here's a whole bunch of red stuff. It says here, com.example.myapplication, which is our package name, fatal exception, main process, which is like our app, has a null pointer exception. And you can even click on this hyperlink here. Well, code is a little bit, let's just go somewhere else. I'm going to click on it. It'll take you exactly to the line that it happened. And you can see here, message, exclamation mark is what caused it. And of course, it's because we made it nullable. It shouldn't be nullable. And I'm just going to reverse all this stuff and then go back to the slides. Cool. So because we probably don't have a lot of time left, I have all the code prepared, and actually the starter code, I got it from this fantastic resource. It's a guy called ResoCoder. I follow him on YouTube. I mean, I'm not one to advertise, but I have learned a lot about Android from him. I think his name is Matt. I think he's from Turkey, and that's his website. That's his. This is the playlist. So if you want to get the full code for the next part that we're going to cover quickly, because I think we're also kind of running out of time, then you can just get it from there. But I've already downloaded it, and I just want to kind of walk you guys through the code that's in there and show you that what we built, which is fairly simple. It's not that hard to kind of create more activities, create more fragments, and have a full-fledged chat app. So we're building a chat app, and we're building it using Android and Firestore. And this is the code. So once again, if you just go to his GitHub, which is ResoCoder, and just download this, which I've already done beforehand. Let me switch over to full screen. Before I do that, I'm just gonna load it up. So what I'm going to do now is I'm going to exit or just hit like the close button for Android Studio. But instead of going back to my application, there's a bookmark here. I'm just going to go to the other one, which I've opened earlier. So now there's a bookmark for it. And so this is the project, right? This is the full code. You should be able to access it later. We're just going to go over the full code. In fact, let's also run it. And it's tied actually to a different Firebase project or Firestore project using a different JSON file. Google Services JSON file, but the idea is exactly the same. If we can create one message on the cloud, we can create a full chat application. So let's go over some of the code that's in there. First, let's talk about the activities and the fragments. So this is essentially all the UI that lives within our application. The app has almost launched. There it is, with the nifty little Firebase logo. So as you can see here, we have this screen here. It shows our contact list. It actually shows our message list. No, it shows our contact list. It says people here. And this is the bottom navigation that I talked to you earlier about. So we have bottom navigation, which means this is one activity, has multiple fragments. So there's people and there's my account. And there's a picture here and some name. And you can update it. So maybe I can select another picture just to show you. So this is like doing start activity for result that we talked about. So under the hood, we're gonna, if we have time, we're gonna go into it. If not, it's fairly straightforward. Once again, all it's doing under the hood is it's starting for activity. The gallery application allows us to pick a picture. I'm gonna go for now a boy and hit save. And once you hit save, it says saving, so it should be saved. It's not like the best UI in the world, but it works. And as you can see, it has been saved. It actually sent it all the way to cloud firestore, saved it on the cloud and fetched it back again. So it's all real time. It all happens kind of on the fly. Let me sign out and sign in again, just to show you a demo of signing in. So I click on continue and sign in. I'm just going to put in like test@test.com. And then next, I've already kind of created an account with that. It's asking for a password, which is test123. Going to confirm. And it has logged me in and shown me the contact list. So this is actually all the people who have downloaded this app. No, not just my contact list. That's kind of the way this chat app is designed. So this is what it does. So there's a profile page. You can sign out. You can save data, and there's a people page. You can send different messages to different people. I did not send that message, by the way. Oh, I did actually, probably, because it's my account, so it must have come from me. It's funny. I clicked on the same one that I clicked last time. Wow, psychology. Cool. So let's go back to the slides and talk a little bit about what's going on here. So we have a bunch of activities. I'm actually going to have to go a little bit faster because we're kind of coming close to the end of this. We have a bunch of activities, the splash activity, which is the firestore icon that we saw in the beginning, a sign-in activity, a main activity, and a chat activity, and 2 fragments. So let's look at them in here. Here are all the activities, as we talked about. These are just different screens. And we also have 2 fragments in the main activity because we have a my account and we also have a people activity. So that's why we have 2 fragments here. We have 2 services. So if we go back to the project, and I'm just going to kind of collapse these and open up the services, you can see here there's 2 services, but we don't have a lot of code. This is because Firebase actually does a lot of the heavy lifting by providing us with a service class that we can just extend. So that already includes all the code. In fact, we can kind of dig into it if you want. Well, it's compiled code, so it doesn't have any comments. But you can click on download sources and it's going to have the full version. But for now, we don't need to. We just know it's a service, and this is my Firebase instance. Now, this does what this does is it fetches what's called a token. This is going to be used for cloud messaging. Every phone has a specific unique token, and you can request a token for your phone, but you do have to save it to the cloud, which is, once again, Firestore, under your user profile, the same way that we sent a message. So now we're going to have to find like a way to create a user collection or users collection, and then create an ID for my user, and then within that document, specify my token. This way, when other users want to send me a message, they can just put my token. Well, they don't have to, of course, put the token. This is done by another Android app or the same app, but like another running on a different phone. It would just under the hood, go to Firestore, fetch your token, and then send a message to that token, which will effectively send it directly to your device. So that's what these 2 methods are for. We have another service here, which is my Firebase messaging service. It extends yet another service provided to us by Firebase, which is Firebase messaging service. And all we have to do is just override one message, which says, what do we do when we receive a message? For now, we just log it. So it's going to show up in logcat. It's going to say FCM, which is short for Firebase Cloud Messaging. And it's going to basically read out the message like to string, basically going to convert it to string and put it out in our logcat, but doesn't really do anything. It just kind of, well, I mean, it will update because I know that under the hood it updates the database, and the database is real time. So it's going to update your user interface, but it's not going to send you like a notification. You would basically have to visit that chat page, and then you will see, oh, look, the message has arrived. But you're not going to get a notification because the Firebase Cloud Messaging is not connected to anything. All these services and activities are actually found in the manifest, much the same way that we were talking about. So these are all the 4 activities. There's probably a launcher one, which is the splash activity. That's the first thing that we saw. There's the main activity. There's the chat activity, sign in activity. That's the one we used to sign in. And finally, the chat activity. We also talked about having some metadata. So Firebase requires you, if you're going to be using, if you're going to be providing an icon, I suppose, there's one way to configure it, and the way to do that would be to provide a, this is probably for the incoming message. So an incoming message from Firebase, you can specify a picture for it. The way to do that would be to put a metadata. I'm sure this came straight from the documentation. You're going to find it there. And finally, the 2 services that we talked about, they're named here by their package name and then by the name of the classes. So, everything makes sense. All our services, all our activities are listed in the manifest as we expect them to be. Let's go to the next slide. There's also some models. These are data classes, and we talked about last time how Kotlin allows you to very quickly create a data class. A data class only has variables. It has no methods. You can just add the word data before it, and then voila, you have a data class. You just specify what needs to go in there. And this is because we want to model the different items that are in our app. So we want a different chat channel, an image message. You're just going to find that these have things that you would expect, like a path for the image, like where to get the image, a time when the image was sent, a sender, a recipient, sender name. So these are just data classes. Model classes are, so they're of type data classes, but these are model classes, and we're using them to model different objects that we're using in our app. We have a chat channel, an image message, a text message, which are both implementations of the message interface. So this is an interface class, and a user object. These are all data classes, very straightforward. We also have 2 utility classes, FireStageUtil and StorageUtil. They live in the util folder, and these are just a bunch of utility methods that what they do under the hood is very similar to what we did. So they just get a reference to a collection or a document, and they maybe add a document to it. Very much like the send message that we did. It's all just kind of bundled up in one class, so you don't have to add it to your activity file and make your activity file super big. And for StorageUtil, just a bunch of methods to upload an image, update profile picture. All the documentation for this is available. I wish we had time to go into it, but I actually have a meeting shortly. But let me just kind of go over the rest of it. So these are just a bunch of methods. You can go over them on your own time. They will match up exactly with the documentation, and all they do is they upload some stuff to the cloud. I just want to touch on one last thing before kind of closing this off, which is version control. Who here is familiar with GitHub? I can't see you guys, so.
Yeah, we're familiar, I think.
Awesome, cool. Thank you, Ariel, for saying that. So GitHub is essentially, it's a way to save your code on the clouds, so on the website GitHub, and it's using what's called version control. Version control is a system that records changes to a file or sets of file over time. It's not specific to Android. You generally use it for all, use different projects, but I do highly recommend you use it in your projects. Android support has support for it, so you can have, like, if we did initialize it, it would show up basically under this Git tab. We're going to see the whole, actually, because I initialized this repository, or did I? It looks like it. Yes, this is not the sample app that we created. This is the app that we downloaded, and I have actually initialized this. So that's why we have this little tree here. We have the initial commit and refactor. Just something I wanted to mention, that Android Studio supports version control out of the box. To tell you a little bit more about version control, it's used for coordinating work among programmers. So if you're working with different programmers, you can submit to different branches. It also allows for speed, data integrity, so you can work fast. Your data can be kind of robust, coming from different people, and also supports for distributed nonlinear workflows. So it doesn't have to be sequential. I can do some work, Ariel can do some work, we can do it kind of in parallel, and then we can push it to our source control, and we can work on different parts of the project, while always having one source of truth, just one version of the product. Thank you all for your time. We don't have much time for questions. I guess I can take 1 or 2 questions, but I do have it. We are kind of on time, and I kind of have to take off. So if you have any questions, now is the time. Shoot them my way. I'm just going to load this and going to switch.
Hello.
Hey.
Yeah, I just wanted to ask, because
with what we learned today, what other type of applications would be like easy to implement for us if we wanted to work on it?
For sure. So the reason I picked the chat app is the most modern day applications have some kind of messaging ability. I wish I could go over kind of the rest of the code, but it will take some time. But the good news is I have provided links to the full tutorial on ResoCoder. He actually has a bunch of videos where he builds the whole thing from scratch, so you can follow it there. I would say a social network would be a fantastic app, especially since most applications have some kind of social networking component. You can definitely, but that's definitely not simple though. It's, involves a lot of moving parts, but Firebase will do a lot of the heavy lifting for you. You could really create an app as simple as you want or as complex as you want. You can create an alarm app. You can create like a notification app. You can just kind of send notifications out to your users. Really, you can do anything. You can build anything as simple or as complicated as you want. If you get an idea for a way to use your phone, make an app for it. No worries. I can take one more question and then I kind of have to go.
Actually, I have a quick one. Sorry, I had my quiz right now, but you mentioned that different builds can have different different modules can have different builds, right? Why would you do that?
Not exactly. No? Okay, so I think you might have misunderstood there. So different, I think there's build types, and build types are basically like a debug and a release version of your app. Modules allow you to have, so a module is like a sub application. So you can have, let's say, within your app, maybe you want to create a module for a library, right? So that's not your main app, it's just some other code. And maybe you can even just create a full Android project that's just a library. So it's going to be one module, but instead of being an app, a full-fledged app, it can be a library. It's actually a really good question because modules, so we didn't really talk about modules, but in this case, I'm just going to go back to Android Studio for a second there. In our case now, we only have one module in the project, which is the app module, and it is an app. We can have multiple modules. So we can have like different applications within the same project. It's better to probably split them up, but maybe you have a good reason to do that. You can also have like a library module and your app module. So then you can package up the library and then maybe send it off to another project. So that's what modules are for. Build types, once again, build types are within, if I go back to Gradle and go to the projects Gradle, so you can specify build types here, you can specify release, but then I'm going to copy and paste this. Maybe there's also a debug version. And then if I do no, don't do that. If I do a sync, then it's going to basically create another version of my project called the debug version. And you can see that if you go into my screen's too big. I don't think you can see it here. Let's see if I can expand this just a little bit. Nope, I cannot. It's actually, okay, maybe if I can just go to the menu here, tool windows, this should be build variants. So as you can see now, we have debug and we have release. We can select, we want to have the release version active or the debug version active. In the debug version, maybe you can use fake data or you can have some kind of logging. And in the release version, obviously you don't want that. You want to use real data. Thank you very much, Laila, for that question. And thank you all for joining me. I wish I had more time to go into the project, but I will provide a link to the code and also the full tutorials for how to build it from the ground up. If you have any questions, please shoot it to me by email. And thank you all for attending. And thank you, Laila, for having me.
Thank you so much. This was so much fun. Oh my God. Have a great night, everyone. Thank you. Thank you.
Thank you, guys. Take care. Bye.
Good night.